oxide has to be reduced. Now you can always use a reducing agent. So reduction can be made from one of two ways, whichever is suitable for the industry. Like for example, if I reduce it with a reducing agent known as carbon, what happens is carbon reduces ZNO and I get the pure metal. Whereas a highly reactive metal displaces the metal and I get Zn. So let's see the reactions. ZNO plus carbon. What will this carbon do? This carbon will reduce. Will it reduce itself or someone else? Someone else, as it is reducing agent. Now, this carbon when it reduces, although its valency is 4 and oxygen is 2, usually it should form carbon dioxide. But carbon, when it is a reducing agent, it cannot reduce more than one oxygen at a time. So it will always form carbon monoxide. So zinc oxide, when it reacts with carbon, it forms zinc plus carbon monoxide. This carbon monoxide is a gas which is given up, leaving behind zinc. So this zinc is a pure metal? No, it is an impure metal which we have to refine. Whereas a highly reactive metal, let's see the reaction which happens in trains. Train tracks are usually broken or there are cracks appearing every now and then. So how do we repair that? We do this. MnO2, that is manganese dioxide, when reacts with aluminium. Aluminium is added as a powdered form. Aluminium, being more reactive than manganese, displaces manganese. When it displaces manganese, what happens is Mn is given out in the molten form. Sir, how? Because it is an exothermic reaction. Mn is positive, O is negative, Al is positive. So Al positive will react with O negative. Al's valency is 3, O's valency is 2, crisscross Al2O3 plus Mn. Now that Mn, because of heat, has come out in the molten state. That molten state Mn is used to fill the cracks in the trains. Hence, the train tracks are renewed. Now, this heat is so high that manganese came in the molten state. So you have to imagine it is not 10 degrees Celsius, 15 degrees Celsius. It is close to 1000 degrees Celsius in heat. Let's see one more reaction. Manganese is in the pure form, whereas Al2O3 is aluminium oxide. This aluminium oxide, being a highly reactive metal, can be electrolyzed. Remember, the theoretical process is difficult, but the practical process is actually nothing. You just have to take the aluminium oxide, drop it into the electrolytic cell, and the process is done by itself. Similarly, Fe2O3, let's balance the reaction before we move any further. Mn was just 1, O is 2, O is 3. So you know the dilemma. O2 and 3 odd ko banao even, multiplied by 2 and multiply 2 by 3. So Al has become 4, so multiply by 4, and Mn has become 3, so multiply by 3. The reaction becomes balanced. Let's come to Fe2O3 plus Al. Now this Al is positive, Fe is negative, O is positive. Right? Wrong. Iron oxide. Iron is positive, oxygen is negative. Whichever ion is said first comes as positive. So iron positive will react with no one, because there is no negative. Positive negative will attract, positive positive will not attract. Al is going to react with O, again form Al2O3, and iron will be given out as pure iron. This iron Fe2O3 is heated in the presence of aluminium. Fe plus Al2O3 plus heat. This heat is so exothermic that iron is produced in the molten state. Let's see what a reaction this is called. Fe is 2, Fe is 1, so I multiplied it by 2. Al is 1, Al is 2, so I multiply Al by 2. The reaction becomes balanced. This reaction is called the Thermit reaction. Why? The heat evolved. The amount of heat evolved in some reaction is so large that the metals are produced in the molten state. These reactions are termed as Thermit reactions. With this, we understood that how to reduce a metal of medium reactivity. Even a lead oxide can be reduced by carbon or a higher reactive metal. Thanks a lot for listening.